Hi, welcome to my video on extra problems in the unit on limits and continuity. So the first problem is find a point where the limit of x squared minus 5x plus k over x squared minus 2x exists when the limit goes to 2. So if the limit goes to 2, that means that 2 put 2 right here and I get 4. Put a 2 here and I get minus 4. 4 minus 4 is 0. So I have a 0 in the denominator. In order for this to exist, I have to eliminate the x. Let's see. I have to eliminate. I have x outside of x minus 2. So x minus 2 is a factor. So if I put 2 in here, I get a 0. So I have to, in order to find where it exists, I have to simplify this to find the value of k, where I'm going to find x minus 2. So this is going to happen at 2. So if I have x squared minus 5x plus k, then if I put 2 in the denominator, I'll get a 0. So if I put 2 in the numerator, I should get a 0. So let's put a 2 in here. Let's see what happens. Let's get a value of k. 4 minus 10 plus k. Negative 6 plus k equals 0. K is 6. So that means I have x squared minus 5x plus 6. So that means that I should have the 6. Let's see, that's an x squared is x and x. Factors of 6 to give me a 5. But because the product is positive 6 and the sum is negative, I have negative and a negative. So the factors of 6 to add up to 5 are 3 and 2, which is one of the factors in the bottom. Because I had x minus 2 here, I needed here for it to cancel out. So it cancels out. So I have the limit as x approaches 2 on x minus 3 over x. So that as approaches 2, I get 2 minus 3 over 2. That's negative 1 over 2. So the point, if this is where it exists, the point is x is 2 and the y is negative a half. So notice I had to eliminate the x minus 2. So to put the 2 in here at x goes to 2, to put the 2 in, I get the value of k. Plug it in, I can factor it, and I can cancel it out, remove the x minus 2, and then I can find a point where it's going to exist. Okay, that's number 1. Let's try another one. And let's sub, without writing all this down again, let's do the cos of pi over 4, the sine of pi over 4, and the cos of 2 times pi over 4. So what does that give us? Pi over 4 is a 45. The cos of 45 is root 2 over 2. The sine of 45 is root 2 over 2. And that's the cos of, that becomes the cos of pi over 2. The cos of 90 is 90 degrees. The cos is 0. So I have a 0 on the, in the numerator, 0 in the denominator. So I have an indeterminate form. Just make the indeterminate form 0 over 0. So that means I have to simplify. So I have the limit as theta goes to pi over 4. Let's see if we can. We have to find a cos of 2 theta. Cos of 2 theta is cos squared theta minus sine squared theta. So the limit as theta approaches pi over 2, so this is different to 2 squares, so this is cos theta plus sine theta, and cos theta minus sine theta, and this cancels out, so I get the limit as theta approaches, this pi over 4. Pi over 4, gotta be careful. So this gives me 1 over cos theta plus sine theta. So if I put pi over 4 in, I get 1 over the cos of pi over 4 plus the sine of pi over 4 sine. That's theta right there. And we have the cos of 45, that's pi over 4 is 180 divided by 4 is 45. Cos of 45 is root 2 over 2. The sine of 45 is root 2 over 2. It's in the first quadrant. So that gives us, if you add these together, common denominator is 2. So that gives me pi over 2 plus pi over 2. So that's 1 plus 2 root 2 over 2. And let's go down right here. So that's 1 over 2's cancel out, root 2. And 1 over root 2 becomes, multiplied by root 2 over root 2, is root 2 over 2. So, notice we had to change cos 2 theta to cos squared and sine squared and factor it out. So when we factored it, they cancel out, and I plugged it back in, and I got the value of root 2 over 2. And I got page 3, it's right here. Almost mislaid it. Excuse me for a second, just turn this over, or turn it. Find the limit as x approaches 4 of x squared minus 2 over x minus 4 by using, so I want to find the limit of this by using its conjugate. So the conjugate of, we're going to do it by the conjugate, and we're going to do it by factoring. So the conjugate is x squared plus 2. X squared plus 2. Multiplying it by root x plus 2 over root x plus 2, it's as a 1, but the conjugate is the root of x, subtract 2 is the root of x plus 2. So that gives us the limit as x approaches 4. And when we multiply, we have x minus 4 root x plus 2. And when we multiply the numerator, root x times root x is x. Negative 2 times plus 2 is a minus. Negative 2 times plus 2 is a minus 4. Notice this is different to 2 squares. So that's an a plus b times a minus b. So that gives us a squared minus ab plus ab minus b squared. So it gives us a squared minus b squared. Because they're conjugates, their product will be the difference of 2 squares. It's x minus 4. The x minus 4 cancels out, so I get the limit as x approaches 4 of 1 over the root of x plus 2. And that gives us 1 over, I'm going to put a 4 in now, so it's the root of 4 plus 2. So that's 1 over 2, root of 4 is 2. 1/4 is my limit. So we did it by the conjugate. Now I'm saying, well, let's do it by factoring. Well, factoring is very similar, only you say, well, what is the difference? Well, the difference is that the root of x minus 2 is that x minus 4 is the difference of two squares, but the square root of x, so that's the square root of x being squared minus 4. So square root of x squared is x. So this is the difference of two squares. So this is the root of x being squared minus 2 being squared. So this is root x plus 2 times root x minus 2. So this is factorable. Now we don't think about that because we're using a root. So that means that's the limit as x approaches 4, root x minus 2. And, oh, I forgot to put down the x minus 4 here, which I will. So that's factorable into root x plus 2 times root x minus 2. And so we got the limit. And what happens? The root x minus 2's cancel out, and I get 1 over the root of x plus 2. And then from here on, here it is, we do this step. So we put the 4 in. I'm doing the same as I'm doing here. And that's 1 over 2 plus 2, 1 over 4. So here, I'm doing it by the conjugate. Here, I'm doing it by factoring. Just to show you that there's two of them. You can do this one either or. You wouldn't have to do it both ways. And that brings us to the end of this unit, and I hope you like my video. If you do, click the like button, click the subscribe button. If you wish, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained, which is one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.